I want to finish off the TypeScript material today. I don't know if I get on to the next topic, the CDK framework, but let's see how far we get. So again, I'm continuing on with these slides here. And so what we know about TypeScript so far is we know about uh, interface data types, which is a way of declaring the structure of a data object in your code. We have looked a little bit at type aliasing, which overlaps a bit with interface data types, but there are other aspects to type aliasing, uh, some of which we've looked at, and we'll see some more examples today as well. We also mentioned type inferencing. That's where the compiler infers a type on a variable if you don't state it explicitly. And I think that's about as far as we got. So the next aspect of the language is optionals. Oh yeah, we talked about functions a little bit as well. And the idea that you need to declare the type of a function's signature. The next thing is optionals, and this goes back to interface data types. And what optionals allow you to do is to indicate that certain parts of a data structure is is optional, is not mandatory. And the way you do that from a syntax point of view is you just follow the property name with the question mark, and that declares it as being optional. So what we're saying in this example here is that if I've got a variable and I say its type is user, then the object that I assign to that, it must have an ID property, it must have a name property, it may or may not have an email property, it may or may not have a social property. If it does have a social property, then within that, it must have a Facebook property, and it may or may not have a Twitter and Instagram properties. And finally, my user object must have a status property. Yeah, so that's pretty straightforward. If we just quickly look at some code examples. So if I go into here. Okay, so there's our user again. And so I'm instantiating some actual objects here. Um, so Joe does not have an email property. It does have a social property. And the only property within his social structure is Facebook. So that's a valid user instance. Jenny has an email, it doesn't have a social property, and has all of the other mandatory ones. Jill has an email and a social property, and within the social it has Facebook and Twitter. So they're all valid from a typing perspective, type safety perspective. Um, just elaborating a little bit more. What am I doing here? Oh yeah, well that's just on the functions side. Oh yeah. Well, in the slides there, I'm saying that this optional um, indicator, that this question mark, you can use that as well with function parameters. You can declare certain parameters of a function as being optional. Now, there is a restriction though. You can only have how will I put it? You can't have mandatory parameters after optional parameters in the function signature. Or put it another way, the optional parameters have to be at the end of the list of parameters to a function. And that's, I think, what's going on in my code here. So I've got a print ingredients function. You pass it in a string, you pass it in a quantity, and then optionally you can pass in a extra info uh, parameter as well. Yeah. So this function either takes two or three parameters. And, just to reinforce, if I switch these two around, if I say make extra info the second part, yikes, didn't want to do that. If I switch those two around now, this mandatory parameter follows the optional one, and we get the squiggly line from our VS Code. And in our problems tab, it's probably telling us, look, you can't have a mandatory parameter after an optional one. So that's fine. I don't have an example of it, but TypeScript does support named properties as well. You can Google it yourselves, but that's all okay. That's all okay as well. Yeah, I'm just doing a little bit more on what am I doing there on union types? Yeah, no, I don't want to go back to the slides again. That's optionals. Back to our type aliases. And there are a number of aspects to it, some of which you've already seen, but another aspect of this type alias syntax is what are called union types and literal types. Union types, we have actually seen it, but kind of covering it formally now. A union type is where you're declaring that a type is essentially a union of other types. So in the example, I'm declaring a type called size, and I'm saying a size variable or a variable of type size could be a string or a number. Okay, so technically we would refer to size as an example of a union type. And then I have an actual variable called glass size with type size, and I'm assigning it a string, and that's fine. I've got another variable called bottle size of type size, and I'm assigning a number to that. So syntactically, that's all acceptable. Another example, type role, could be a student, lecturer, or manager. Now, each of these presumably, that might be an interface data type. That might be defined as a type alias. You might remember there was, when I mentioned type aliases first, I said that to an extent they overlap with interface data types. And you can mix and match them as we are here. Manager, I don't know, maybe that's an interface data type as well. So again, that's a union type, or sorry, role is a union type. And then I'm declaring an actual variable of type role, and I don't know, whatever the structure of a student whatever a student's data structure is, it's assuming and assigning it there. So that's the union types. Literal types, we have actually seen as well, but I didn't give them that kind of formal name. A literal type is where you're declaring a type, but you're assigning or you're stating that an instance of that type has to have one of a subset of actual values. The example hopefully illustrates it. So I've got a type called degree nomination, and the only valid values for a variable of that type are BSc, BEng, and so on across. Then I declare a variable of degree nomination, and I have to assign it one of these actual literal values hence the name literal type. Otherwise, the compiler is going to complain. And I think there's more examples of that in the code. So I've got this is kind of going back to my user at the top of this file. So I'm declaring a type called social handles, and this is its structure. I'm declaring a type called address, and this is its structure, both mandatory properties. Then I'm declaring a type called contact. This is an example of a union type, and I'm saying a contact is either a social handle or it's an address. And I'm declaring a type called user v2, and the only interesting property is this one here, a property called contact of type contact. So, and then I've got actual variables. I've got Kyle, which is a data structure of type user v2, and it looks like Kyle's contact property matches the shape of social handles. I've got another person called Jenny of type user v2. Her contact property, its shape matches the address. So again, from a type safety perspective, both of those objects, Jenny and Kyle, they're both valid objects of type user v2 because of the way I declared what the structure, what is the nature of the contact type. Um, oh yeah, this is kind of an interesting. So I've got a function here called getContact, and it's passed in an object type user v2, and it returns a string. And the idea is that it returns, or my thinking was that it will return the person's contact details in string format, stringified format, let's say. So in the function, I need to declare within the function, or I need to determine within the function, is the person's contact, is it an address or is it a social handle? Yeah. And so that's what I'm doing in this if statement there. And the only way I can really do that in my code is check to see if there's a particular property in the contact structure where that property is definitely belong to one of my two options, address or social handle. So I'm checking whether it contains street, okay, whether the contact property contains within it a subproperty of type named street, and that will tell me that the contact is an address rather than a social handles. Now, where I'm getting to though is if I do Control K, Control I on this here, or sorry, Command K, Command I, it's telling me, what is it telling me? Let's just create some space for myself, and let's pull this down. Now, try that again. Okay, it's telling me that it's of type contact. Yeah, that makes sense. But if I do the same here, let's say here, right? Command K, Command I. That's not what I wanted. Sorry. Sorry now. Why are you doing that? It's not behaving the way I want it to. It should actually tell me that it's of type address. Why are you not doing that? Okay. See here, it's telling me it's actually of type address. So what's going on there? Well, what's going on is the compiler has actually worked out, well, if this condition evaluates to true, then user.contact is indeed an address structure. In other words, it has narrowed the structure down from being a contact structure to an address structure. And when I did Command K, Command I on this variable here, it actually told me that. The compiler told me that. So the compiler, is quite clever in that sense. It follows the flow of control in your code, and it's able to perform what's called type narrowing. Here's a question. If I do Command K, Command I on this guy, what is it going to tell me? Anybody want to have a go? Is it going to be of type contact or address or social handle? No, let's ask it. It's of type social handle. Why? Because from a flow of control point of view, because there's a return statement, maybe it's not that obvious though, but because there's a return statement here, that means from a flow of control point of view, the only time it will get to the beyond the if statement is when essentially this if is false, which means that the contact structure is of type social handle. So it's only ever going to come down here to this bottom part of the function when the user's contact is of type social handle rather than address. Okay, I'm not going to dwell on it any further. You can play with it yourselves, but I guess the overall point I'm trying to make is that the compiler is working away behind the scenes and it's making clever kind of decisions for you. Like I will make one other point, right? If I try and go dot here, like I want to index into my contact structure. See the way here, the only option that's giving me is, well, it's either dot street or it's dot town. They're the only two properties of contact that make sense within the code here. And that's because it is worked out that the contact in this case is an address. Similarly, kind of down here, if I go dot, then it knows, well, it's either dot Facebook or Twitter or Instagram. It can't be dot street or dot town because contact can't be an address once the flow of control gets to this line. Right. Seems like you're not impressed by that, but that's okay. Let's move on. So next topic is generics. Generics is a feature of lots of programming languages. The first time I've come across it was in the Java language many, many years ago, but lots of other languages have it as well. Don't know if you've probably used generics in some programming along the lines, whether you were kind of aware of it or not. But so the general idea anyway is that like something we love in software engineering is reusability. We like writing code that we can reuse. Now, a simple example would be, when you declare a function, you can reuse it in many places. And similarly for a class. What generics allow us to do is if we stick with functions, for example, generics allows us to parameterize the data types of the parameters of a function. So function, maybe the function is going to be usable for different types of parameters, not just values of the parameters, but different types of the parameters. Hence, the function is parameterizable at the type level, and therefore it's reusable. So we have this notion of a type variable, which sounds kind of contradictory. Up to now, when we talk about variables as having a type, but now we're talking about a variable actually, its value is actually a type rather than an actual literal value. From a syntax point of view, I'm showing you a simple example here, and the example is in the context of functions, using generics with functions. But as we'll see, we can use generics with other constructs as well. But whenever you see this kind of angle bracket in TypeScript, then you know that generics is at play here. So I've got a function here with a terrible name called process. And the way you and this function takes two parameters, it looks like. The second parameter is of type number. That's okay. The first parameter is of type t, and t also appears over here. Now, and we don't care about the body of the function. Now, when I invoke this function, I have to indicate a kind of a value for t, but the value is going to be a type, not an actual literal value. For example, here I'm invoking process and I'm assigning the type person. So presumably person has been declared somewhere else, either using interface data types or type aliases. That now means that this parameter here, person X, that parameter is of type person, because up here I said that the first parameter, its type matches whatever is inside the angle brackets. Here I'm invoking the same function, but I'm saying I want t now to be bound to the box type, which means the first parameter is of type box. Now, clearly, like within the function itself, we'd have to have some kind of conditional statements that determine, well, it may need to determine what exactly is t. It may not if the nature of if the nature of the processing can be generic to whatever the type is, hence the name generics. So that's just the syntax of it anyway. I wouldn't expect people to be able to, like, the trick with generics really is identifying opportunities to use it in your code. And that's not straightforward, for sure. So I guess unless it's a very simple case, it may even not be obvious to utilize generics within your code. But certainly, you need to understand generics when you see it in TypeScript. That's really my objective. I'll give you an example, kind of a dreamt up example, but serves the purpose, hopefully. So let's close off that guy. Now, I kind of build up the example. I first of all show you some code that is not using generics, and then I say, well, if we use generics, here's how we'd write the code. That's kind of what I was trying to get at here. First of all, nothing to do with generics. I've got an array of strings, and I'm invoking the sort method stroke function on my array of strings. And you know what sort does. It performs, technically performs a bubble sort, but the criteria for the sort, because sort works on an array, and it could be an array of anything. It'll work on any type of array. So you have to pass to the sort function. You have to explain to it essentially on what policy should it use to do the bubble sorting. And you do that by means of a callback. Okay, this is my callback. So it looks like I'm using the length of my strings to control the sorting. Yeah, so that's just sort. That's nothing to do with generics. It's nothing to do with TypeScript. Sort is available in JavaScript. So my callback helps the sort to do its thing. That's fine. I then decided I'm going to create my own function called string ranker. This is just an ordinary function, no generics involved here. I pass it an array of strings and I pass it a callback, which I've called ranker. And my idea here is that this second parameter will be used by the sort, because if you look in the body of my function, I'm calling sort again, but I'm using the ranker that was passed in to control the sorting. Yeah. So it's not really a big jump from there to here, really. And in truth, I suppose string ranker is probably not worthwhile writing, but it's fine. And here I'm calling my string ranker. I'm calling my string ranker here, and I'm passing in, here's my ranking criteria. Yeah, so again, I'm just using length as the criteria. So that's string by length. I might have another invocation of string ranker where the ranking function, let's say it counts the number of vowels in the string, and that's what the sort uses to sort the array of strings. It's always sorting in ascending order. Console log kind of confirms if you're not sure what's happening there. You can look at that yourselves later on. I've got another function called person ranker. And if you look at the body of the function, from a code point of view, it's the exact same as string ranker. But in this case, my person ranker function, again, it takes two arguments, but the first one is, this time it's an array of person objects. And my ranker function is dealing with person objects. And I've decided, I think I wanted to use a person's age as the ranking criteria. This function here, like it always has to be a function that returns a number. And that's because, if I go right back to here, that's because of sort really. Sort always expects a function that returns a numeric value. And that expression there definitely returns a numeric value. However it computes a numeric value, it doesn't care as long as it's always a numeric value. Otherwise the sort won't work. So back to my person ranker. So that's why this guy, from a signature point of view, it has to be a function that takes a person and returns a number. Now, person in my case is, I've just imported it. If we have a look at it, this is what person looks like. But notice here, not for any particular reason now, I've made the age property of person optional, which means there will be person objects that do not have an age property in them. Okay, that's worth remembering. And I kind of intentionally complicated it by doing that. And I did that to illustrate another part of TypeScript. So we're kind of juggling a couple of balls here now. And let's just, again, forget about generics now for a second. I want to cover this other aspect of TypeScript with you. So where were we? Back to, where am I? Down to here. Okay. So I've got some person objects, Joe and Jill and uh, Jane. And notice Jane does not have an age property. Okay, so far so good. Now I invoke my person ranker. I pass in my array of person objects. And I want to uh, sort my person objects by age. So you might think, well, why not just go get rid of all this garbage here and just go, like that. Just return the age of the person and use that within the sort. Wouldn't that work? But I'm getting a squiggly line here. Compiler is complaining. And if I look at why is it complaining? Uh, it's telling me that because age is an optional property, then there will be cases when it's undefined, its value is undefined, right? It won't be numeric. And the ranker function has to return a numeric value. And so for a person object that doesn't have an age, it's going to return undefined. And that's going to mess up the sort function because now it's trying to decide is 3 greater or less than undefined. Now in JavaScript, if we were writing all of this in JavaScript and all of our code so far is valid JavaScript, you're not going to find out that there is a potential bug in your code until you run it. And even when you do run it, if you happen to not have a person object that does not have an age, well, you're going to think my code is working. It's sorting my person objects. Maybe 6 months down the line, somebody creates a person object and adds it to your database or whatever, and then your person ranker starts to sort them, and suddenly your application crashes, and you have to work out, well, why is it crashing? It was working up to now, and it's crashed because we've eventually come across a person object for whatever reason that doesn't have an age property. That's the downside of JavaScript. You don't identify these things until runtime. Whereas with TypeScript, it's complaining straight away. It's kind of looking forward and saying, well, you could eventually hit a problem here now if you have when you hit a person object with no age property. And that's why we're getting this squiggly line. And so the compiler is forcing you essentially to deal with this scenario when age is undefined. And I've just arbitrarily decided if there's no age, then default to 30. And certainly now the compiler is happy because you're dealing with the undefined case. Again, this is another example of the compiler's kind of cleverness behind the scenes. That's great. It's nothing to do with generics though, but it's just another indicator of the kind of power of the TypeScript compiler. Back to generics though. So I've got a person ranker function. Where is it? Here. Person ranker function, which structurally really is the exact same as my string ranker function. Can we not combine them? And the answer is yes, we can. And here's how we will combine them. Where do I combine them? Oh yeah, okay. So here's my generic ranker, terrible name for a function. It has one uh, it has one type parameter. There can be many, right? By the way, as well. So, and by convention, you can call the type variables anything you want to, but conventionally we tend to give them capital single letter names like T, S, U, V tends to be the convention. Don't know why. And there can be many of them. So if there were more than one type parameter for your generics function, then it would just be you'd comma separate them between the angle brackets. The first parameter is an array of t's. And the second parameter is a function that takes a t and returns a number. And here's the body of the function as before. Here I'm invoking my generic ranker. I'm telling it, look, I want t to be bound to the person type. And I'm passing in an array of person objects. So from a type safety perspective, they all match up. So it's not complaining. And here's my kind of ranking criteria, same as before. Um, Here I'm using my generics with strings. But if you notice here, so here's my generics. I'm invoking the function here, but I'm not telling it it's strings that should be bound to the t type variable. But I'm not getting any compilation errors. And what's happening there is type inferencing is kicking in. Type inferencing in this case, it essentially looks at this array here. It sees that it's an array of strings, therefore it infers that t must be of type string. So just more type inferencing going on. Okay, generics is not just related to functions. You can relate it to other constructs within the language. And I'm just kind of a make-up example here. I've got an interface data type called microphone, another one called speaker, and I've got another one here called box, but box in this case is a generics uh, use case. And a box, it is a data structure. Okay, this is an interface data type that's been declared here, but it's parameterized. And so the properties are shelf number, which is this a number, and contents, which is an array of whatever t's are. And so here I'm creating a box of speakers, and the actual array of boxes, these objects have to be of speaker structure. Their structure has to match the speaker type from a syntax or type safety perspective. And you can use generics with classes and type aliases and pretty much everything else. Any questions, I wonder? Just go back and look at the examples yourself, and it turns up in the lab as well, so you get a chance to. I don't know if I have got an exercise on generics, but okay, that's generics. The last aspect of TypeScript that I look at, but of course there are lots of aspects that I'm not going to look at, is what are called utility types. And utility types, formally what they are they are type transformers. And there's a bunch of utility types, and but the name kind of implies that they're useful types that are custom types in a way that come with the language. They're not native to the language. They've just been added in as extras, custom extras by the designers of the TypeScript language. And also the open source community have come up with lots of other utility types, but those ones don't come with the language when you install it. You have to install them as a separate library. And we won't be looking at those, but we will just look at one or two of the built-in utility types. And they happen to avail of the generics syntax as well. This screenshot here is just from the online TypeScript uh, documentation, and there's a whole section on the various utility types. There's some of them are very useful, others, they're maybe not as useful, but just to give you an example of them from a syntax point of view. So we're down to here. Again, it's kind of making up examples, but hopefully to get the point across. So I've got an ordinary custom type here called tech user with these properties. And here's where I'm using one of the utility types that come with the language. There's a utility type called partial here. All of these, well, any of the utility types I've looked anyway, avail of the generic syntax, and that's what's going on here as well. So what the partial utility type does is it essentially takes an existing custom data type and makes all of its properties optional. So the way you tell it what custom type you want it to work on is the first type parameter. Well, that's that. There's only one. So, and I'm assigning this to a new type for myself. So if I do Command K, Command I on this one, you can see that all of the properties are optional. And that's all the partial utility type does. So there may be cases where you want to do that. And I'm actually showing you the kind of classic use case of using partial. I've got a merge function. I've got a merge function here, and you pass it a user, you pass it a tech user object, and you pass it an instance of my tech user partial, which again is a terrible name, but tech user optional, sorry. And all the function does is it's a bit like an update. I want to perform an update on the properties of my tech user. And it's only some of the properties that are going to be updated. So I'm essentially creating a new object here. Does anybody know? See this dot, dot, dot here? What's that all about? Maybe I'll just go back for it. I'll take a step backwards now. So I'm creating a function here. Yeah, I'm creating a function, just using the arrow syntax, passed in two arguments. And the function, what it returns is a tech user. And the function only has one statement in it, really. It's just a return statement. The return statement is creating an object. Okay, and it returns that object. And in the creation of the object, I'm taking user and I'm going dot, dot, dot in front of it. Can anybody remember what's the name of that?
It spreads the properties of that object.
Yeah, it's called the spread operator. So it's essentially taking the properties of this object and individually spreading them out into my new object. And then I'm doing the same with this guy. But of course, this second one, the overrides, it's going to have properties that are the same name, the same key as in the user. And the second one is always going to take precedence. So I'm essentially kind of overwriting some of the properties in user. Okay, I'm doing a merge of these two. Anyway, that's just that's your kind of classic use case of partial. Moving on, and you can look at the console log of that if you're unclear about it. Another fairly well, maybe not so, is the required utility type, and that does the opposite of partial. The required utility type, it also only takes one parameter, one type parameter, and it essentially makes every property of the parameter mandatory. So again, if I do Command K, Command I, I think we had email as optional in TechUser, but now it's mandatory here. So it's again, what we said about utility types is that they transform one type into another, and that's what's going on here. You can look at the example of it being used yourselves. Did I skip something? Oh yeah, pick is another utility type, and that allows us to pick certain properties of this type and put them into a new type. So I want to pick email and name. It's unfortunate now it's the OR operator here. You don't interpret that as an OR. It's really this and this. I guess there was some good reason why they couldn't use the and symbol there. Probably just got too difficult to compile it. So that means that this new type here is going to be a type with just two properties, hopefully. Yeah, that's pick. The opposite of pick is one called omit. And with omit, it takes the first type parameter and it omits these properties from that. And what's remaining then is what's put into the new type. So again, Command K, Command I. There's no ID property and there's no email property. Moving on. Okay. Yeah, I thought I had an example of something else going on there now. I'm just looking for it. Just give me a second. No. Okay, the next one I'm demonstrating is this record utility type. And maybe if I just show you it running first, because it can be easier to, if I show you the result, you'll grasp what it does. So if I just run this. Okay, so it's supposing uh, I've got an array of, or a collection of TechUser objects, and I want to create a map data structure where the keys in the map is a TechUser's ID, and the value is a subset of the TechUser's properties. And that's what we're getting here, right? So let's supposing I've just got two TechUsers. I've got one TechUser whose ID is 1, and the name is that, and some other properties as well. Another TechUser, their ID was 2, and I think, yeah, these are some other properties. So I want to create this data structure. But from a TypeScript point of view, how do I uh, describe the type of that data structure? Yeah. And that's where this record utility type comes in. So here we go. I want to declare a type called a TechUser map by ID, because this is essentially kind of a lookup map. We often refer to it as. Yeah. So TechUser map by ID. want to create that, and you see the structure of it below now. So what the record utility type takes is you first of all tell it what is the type of the keys in my lookup map. And here, this is how you actually refer to a particular this is how you refer to a particular property within a data type. You use the subscript notation. So TechUser subscript ID, what that expression evaluates to is the type of the ID property in TechUser, which I think was string. Was it string? Number, okay, it was number. And then the second parameter to my record utility type has to specify the structure of the values in my map. And I've decided, look, this is the structure, and that's a type that I defined earlier on, somewhere up above. So that's what record does. It's a way of describing the structure of an object where the kind of object is being constructed at runtime. And that's essentially like this lookup map is constructed at runtime. I have some code here which actually creates the lookup map. TypeScript won't do that for you. You have to programmatically code it. But from a type safety point of view, I want to be able to state what is the structure of the map. And then I've got, here's my function that does it. This is just code, right? I'm passing in an array of tech users, and you can look at the code yourself. It's mapping over them and doing some creating the map, creating the lookup map as it works its way through. I don't really want to talk through this. You can look over that yourselves. So record is actually it can be quite useful. The record utility type can be quite useful for those kind of scenarios. Otherwise, there's no other way of sort of describing the shape of this thing. Any questions, I wonder? No, okay. Now that's all I really want to cover in the language. I'm covering as much as there may be one or two other aspects of the language that we will come across when we start looking at the real topics of this module, which is infrastructure as code and serverless and all that kind of stuff. And I can explain those as we hit them. I do actually just want to go back to one other something way back. This is the built-in type hierarchy that comes with the TypeScript language. Yeah. And at the top of the hierarchy is the any type. And you might think, oh, well, you never come across that, but you do actually. So if I want to spend just a minute on the any type, just to explain what it is, first of all. So let's go back to here. Again, it's a make up example. So I'm declaring a variable here, and I'm explicitly saying it's of the any type. And that simply means that any value can be assigned to this variable. And I'm proving it, like I'm assigning a string to it here, and on the very next line, I'm assigning an array of numbers. And there's no squiggly lines from VS Code, so there's no compilation errors. And that's because I've said, look, I'm allowing any value to be assigned to this variable. I don't care what type of value is going to be assigned to this variable. There may be some rare, obviously, it's something you should minimize, if not totally eliminate from your code, because it's really, if you start making variables of type any, then you're writing in JavaScript at that stage. You're not writing TypeScript at all, and it kind of defeats the whole purpose. So that's the first point. The second point is sometimes the compiler, if you've got very complex code, the compiler will infer the any type on a variable. And you can control whether you want the compiler to warn you about that at compilation stage or not. And the way you do that is, and I didn't mention this when I introduced TypeScript, if you see this file here, this tsconfig JSON file, that's in that file you can configure, as the name suggests, you can configure your TypeScript compiler. Now you can see, look, there's lots of options that you can enable or disable. One of the options you can control is whether you want the compiler to warn you about it inferring the any type on a variable. If I just do a search for it, you should, in general, I think you should probably stay away from this tsconfig, because if you start playing around with it, then you'll just get caught up in a loop, really. Although there is one or two cases where I tell you to make changes, but let's stick with the yeah, see this property here. Sorry, this one here. So if I enable this, it's disabled at the moment, but if I enable this line and I set it to true, I'm telling the compiler, warn me if you infer the any type on a variable. In other words, it's going to pop up as as a problem, in the problems tab here. Okay, that's just any. There's also an odd one called, see this one here, the unknown type. There's a slight difference between any and unknown. When you explicitly declare a variable as being of type any, then you're essentially kind of saying, I don't care what type of value is assigned to a variable. There may be edge cases where that actually makes sense, but that's what the any type is sort of saying. I don't care what type of variable is assigned to sorry, what type of value is assigned to a variable. Unknown is where you're saying, I don't know initially what type of value will be assigned to a variable, but within my code, I will determine the type. Okay, so it's slightly safer, they say. Using unknown is safer than any. I don't know, this may seem like a little bit of a theoretical discussion, but anyway, let me just give you a simple example of where the unknown type, just an example of it now, really, rather than a typical example of it. So if I do this, so I've got a variable called unknown var, and its type is unknown. I haven't initialized it. There's no problems. Type the compiler isn't complaining. So it's saying that's okay. And then here I've got a line. What's it doing again? Where I'm multiplying my unknown var by 2 and I'm assigning it to another variable. And now I'm getting a squiggly line. And the squiggly line is because the compiler is saying, I don't really know whether the multiply operation will work on this variable because you haven't really told me what type of variable it is. It's unknown. Okay, so that means, so how do we overcome that? The way we overcome it is we actually have to put it into our code. We have to tell the compiler, only do this multiply operation if the type is numeric. And so that would be just an if statement. So I've got the same line of code here, right? I'm multiplying unknown var by 2 and I'm assigning it to another variable. I'm not getting any compilation error. Yeah, it's happy. And that's because I've preceded, well, I've conditionalized this statement by virtue of this condition test here. Now, I happen to be using the type of operator which I mentioned to you the last day. That's just coincidental, right? It makes sense in this case. I'm checking is unknown var of type number. And if it is, then execute this statement. And it's a bit like the type narrowing that I was mentioning earlier on, in that the compiler is following the flow of control. Okay, you set up here, you don't know what type unknown var is, but here you're saying only if it's of type number should you execute this statement. And that's fine. It's happy with that. If unknown, if unknown var was assigned, I don't know, a user object in some cases, and the nature of what was going on in terms of processing the unknown var meant that it had to be of type user, then the if statement here would have to in some way express the condition that only if unknown var is assigned a user object structure should you execute what's inside the body of the if statement. I haven't shown you how to write that in TypeScript code. You can't use the type of operator for your own custom types. The type of operator only works with primitive types built into the JavaScript language. Okay. So anyway, they're just kind of the two edge cases there of any and unknown. Unknown is used a lot when you've got code that is talking to a remote web API, and the structure of the data that's returned by the web API could be of a number of different shapes. And so in your code, you have to work out, well, which shape is it or which data type is it? But you have to do that in your code. Okay. I don't know if that's any way of interest to you, but there you go. So where are we on time? We're 20 past 12. So you are now in a position to finish this lab, and I've made the hand update for it tomorrow week. So you've plenty of time to walk through it. And you can see there are sections on functions and generic options, type aliases, generics, utility types. So I've tried to cover the full suite of topics that I've covered, but as I've already said, there are a number of other topics that we just haven't time to look at. Again, I'll just pause for a minute in case there are any questions coming to you. No? Okay. So TypeScript is really sort of foundation topic, if you like, for this module. Another foundation topic is infrastructure as code. So that's what I want to talk about next. Now, if you're eager and you want to start working into these labs as well, can I ask you to, well, obviously you've got to create your personal AWS account first. And when you do that, it's considered good practice, or it's considered bad practice to always access or log into the management console using your admin credentials. When you create an account, you're essentially you're the admin user for that account and whatever the credentials associated with that admin user is. Now, it's considered bad practice to log into the management console using your admin credentials on a kind of a regular basis for security reasons. Instead, what you're advised to do is create an IAM user, and you may be familiar with this from your module in third year, but I'm kind of reinforcing it here. So once you have created your personal AWS account, just follow the steps in this lab here, which steps you through creating an IAM user. And then for the rest of this module, every lab that you will be working your way through, you should really be using your IAM user credentials to access the management console. And also to configure your AWS CLI, that command line tool that you use for talking to the AWS cloud from the command line. You need to configure that as well. Tell it about your IAM user credentials. And I think the lab kind of steps you through the whole process. So do that before you start on this lab. I don't really require people to start on this lab this week, maybe at the latter end of next week after you've completed the TypeScript one. So I want to talk about this Cloud Development Kit, or CDK kit. There are two versions of it, but I kind of always mention this at the beginning when I deliver this module, but it's probably redundant now at this stage. The reason I used to remember it, or used to mention it to students, is, if they were Googling CDK, they might hit articles that are using version 1 of the CDK, but that hardly applies anymore, really. It's unlikely now that you would come across an article that's using version 1, albeit it's only maybe 3 or 4 years old. But so it's version 2 of the kit that we're using anyway. And this CDK tool is a way of achieving this infrastructure as code objective. And so to kind of set the scene, why do we need infrastructure as code at all? And I appreciate now that you probably are already familiar with this from the DevOps module, so we're kind of overlapping a little bit. But something that we like is kind of our goal here is that we'd like to have a reliable and consistent way of provisioning infrastructure. Consistency and reliability, both of them really, because we may want to create a particular infrastructure multiple times. Maybe you want to create the infrastructure in a development environment. You want to do some application development and deploy your application to that infrastructure. And you want to replicate the exact same infrastructure when you're subjecting your new application, your cloud app, to testing. And obviously, you will want to have the exact same infrastructure for your production environment. So we want to make sure that the infrastructure that we create for these three environments is the exact same in all cases, hence the kind of consistency objective. Similarly, or equally, if the application that you're developing is going to be used kind of globally, then you may want to deploy that application into different AWS regions. Okay. And so you have to replicate the infrastructure in each of those regions. And you want to make sure that it is the exact same infrastructure in each region that is being provisioned. So they're sensible kind of objectives. Now, if the way we provision our infrastructure, certainly if it's a manual approach, then there's no guarantee of consistency and reliability there, unless it's the same person that's doing it every time. And even then, you're not guaranteed consistency in the infrastructure. So we'd like to automate it, is kind of where we're heading with this, to automate the the provisioning of that infrastructure. We always talk about having a single source of truth. If we take a manual approach, okay, we may document the manual approach, but that document, there may be multiple copies of it floating around the place, and they may not be the exact same, and all those issues. So there is no single source of truth if it's simply a documented process. And so we want to automate the provisioning of the infrastructure, and the term that we use for automation of provisioning of infrastructure is infrastructure as code. We want to implement as code the provisioning of infrastructure. Anything of use here? Well, okay, I'm not going to go over those. I think I've kind of made those points already. Of course, by implementing it as code, we can subject it to version control, publish it on a GitHub repo and use version control on it, which is great. Can't really do that with documents to a degree anyway. You now have a single source of truth of how your infrastructure is provisioned. Your single source of truth is your GitHub repo. And all of the other stuff, rollback changes, that's easy. It's easy to roll back a GitHub repo. It's not easy to roll back a manual document. That's all okay. You're probably also familiar with this, but like the infrastructure as an idea has been around for a while, and it's gone through a number of iterations. Now, the first attempt at it was just bare bone kind of scripting. So on the right here, I'm showing you, you've got different services available, and we're sticking with the AWS cloud environment, but the same applies to Azure and Google Cloud. We've got a number of services, and what the cloud provider, AWS in our case, did early on in the history of cloud is they provided a web API interface to each of these services. That means we could communicate with the service over the web. And they also, in conjunction with the web API interface, they also provided an SDK, a software development kit, which allows us to programmatically communicate with these services for the purpose of creating resources within these services. And if you remember in the developer operations module in third year, he would have written Python scripts, I'm thinking, and he would have used a library called Boto3, I think. So Boto3 is the SDK provided by AWS for the purpose of communicating with their services with the objective of creating resources, instances in those services. In other words, creating infrastructure. Am I right about Python and Boto3? No, assume I am. So we go in and we write a Python script, and the Python script is using the Boto3 library. And when we run our script, it's essentially communicating with the various services for the purpose of creating resources in those services. But there's lots of problems. There was lots of problems with that approach. For example, if halfway through the script there was an error, then that now means that some of the infrastructure that was created at the beginning of the script, that infrastructure exists and has been created, but the infrastructure after the error has not been created. So we now need to kind of manually go back and undo the infrastructure that was created by the beginning of the script, correct our script, run it again. Let's supposing it runs successfully, and that's great. Now we want to make some configuration changes to some of the resources that have been created over here. what do? We either go in and do it manually, or we write a completely separate script that carries out the updates to our resources. So it just gets it's just a little bit messy, and it's certainly not a good developer experience. And also there's the fact that your script is communicating asynchronously. Then how do you know when, let's say in your script, it asks the S3 service to create an S3 bucket? How do we know whether the bucket has been successfully created and configured? You could kind of programmatically do it okay, but it becomes very unwieldy. So there were lots of um, downsides to this approach. The cloud providers, AWS and the others, what they then did was they created a special service called a resource provisioning engine. And the resource provisioning engine kind of does all of the heavy lifting for you. So you had to do less from a scripting point of view. And also, and again, like I'm assuming people are already familiar with this, but I'm kind of reminding you. So with the resource provisioning engine, so that's just a separate service. And what you do as a developer, let's say, is you describe the infrastructure, or you declare the infrastructure that you require to be created in essentially a configuration file of type YAML or JSON. Mainly YAML, I think, is what people use. So this here represents a declaration of the infrastructure that we want to have created, and all of the configuration settings for each resource within that infrastructure. And we refer to this as a CloudFormation. CloudFormation is the name of the service, sorry, this resource provisioning engine. And the YAML that we write is referred to as a CloudFormation template. You essentially upload that to your CloudFormation service, your resource provisioning engine, and it takes care of communicating with the individual services and getting them to create the resources within them. So this is really doing the work that previously we had to program here ourselves. Also, when it came to you wanting to update some of the, or change some of the configuration of your resources, you went back to your single source of truth and you just made edits to that. Essentially, what this template is describing is the desired state of your infrastructure. So you made edits to this, you sent that up to the CloudFormation service, and it knows what the current state of your infrastructure is, and it simply compares the current state with the new state, and it works out what changes need to be made to your infrastructure and communicates that accordingly with the services. So as I said, this is doing all the work for you. As a developer, you have to write your CloudFormation template. A separate company called HashiCorp, what they did was, yeah, the problem with these templates is that they can be quite long-winded. Well, sorry, no, that's not the point. What HashiCorp did was they came up with a solution that will work with any cloud provider. These CloudFormation templates only work with AWS, but if you want to work across multiple cloud providers, this isn't going to work. HashiCorp came up with a solution that works for all of the main cloud providers. And I think this slide is just repeating some of the points that I've made. The downside of writing these CloudFormation templates is, okay, the title is infrastructure as code, but you could hardly say that writing YAML is like writing code. YAML is a declarative syntax. It's not imperative or procedural. So this, you know, saying that it's actual code is a stretch at best. So the configuration syntax here I'm saying is not developer friendly. There are no kind of abstractions built into the YAML that you write because you're dealing with low-level resource configuration properties. Hence, your configuration code, your CloudFormation templates are quite long. That's the verbosity point there. So they were the disadvantages. How do we overcome those, or what solutions are available to us as developers to deal with these downsides? This slide is kind of telling the same story. So at the beginning, the cloud providers provided a web API interface to the various services. They also provided an SDK to simplify communicating with the services rather than writing raw HTTP. Then they provided the resource provisioning engine. And the key point about these resource provisioning engines, CloudFormation, for example, is that they manage the state of your infrastructure. They understand state and they know how to update state and they know how to roll back the state of your infrastructure. So state management was one of the key advantages that these resource provisioning engines provided us with. Enter the CDK framework, which is an AWS specific framework, does not work with the other providers. So that's one of the downsides of it. And so in terms of our layering here, our kind of onion layers, the CDK framework, it talks to the CloudFormation service. It also understands state management. But the difference between the green and the blue is you describe your infrastructure using imperative code as opposed to declarative code. And the imperative code can be in almost in any language of your choosing. So you can write your imperative infrastructure as code in TypeScript or Python or Java or Rust or C# or Go, and there are probably some other languages as well that are being added to that list. And in order to write your infrastructure as code in any of these languages, you've got to use this CDK framework. And the CDK framework comes with lots of quite a large class library built into it. And we will see ourselves using this class library in a while. And also the good thing is that unlike the YAML CloudFormation templates that you write, using the Cloud Development Kit, the CDK kit, it assumes certain default settings for whatever resource you're trying to create. And the defaults are usually the most common settings for the various configuration settings of whatever resource, whatever infrastructure resource you want to have created for you. So there is less syntax that you have to type when you're using something like the CDK framework as opposed to writing raw YAML infrastructure as code. Which is the point that I'm making kind of down here. I'm saying that CloudFormation lines of code is usually much greater than CDK lines of code. So, developer productivity, we say, is improved by using the CDK as opposed to writing raw YAML. You can actually do unit testing of your infrastructure as well, although we don't look at that. Okay, so talking a little bit more about the CDK framework. Whenever we start using a framework, we need to understand the kind of the concepts that the framework requires us to use and to utilize. Essentially, there are four constructs. So we talk about writing or developing a CDK application or a CDK app, although it's not an application in terms of functionality now. It's an application that whose purpose is to create infrastructure. But because we're talking about programming, we always talk about applications. But an application in this context means something that will, when it's executed, when the application is executed, the result is some infrastructure is going to be created in the on the AWS cloud. An application is made up of a number of stacks. Now, stack is a term that we use when we talk about the CloudFormation service itself. So that's not so it's borrowed that term from the underlying service, the CloudFormation service. But from the CDK's point of view, an application may be comprised of a number of stacks. In pretty much all of our cases, there will only be one stack in our application. A stack is made up of constructs. Pity didn't come up with a better name, but a construct, as we'll see, and there are many constructs that come with the CDK framework, but a construct typically creates, when it's executed, it creates a number of pieces of infrastructure. A construct is made up of resources, and resources is also a term that we use when we talk about the CloudFormation service. A resource is a single piece of infrastructure. So a resource might be a single S3 bucket, a single EC2 instance, a single IAM policy, a single security group, and so on and so forth. But a construct would create perhaps a number of resources typically. And the graphic then kind of shows you the hierarchy that's going on here. And so when we run our CDK application, it's actually talking to, well, sorry, maybe I explain that on the next slide. The only point I'm making down here at the bottom is, if you've got a CDK application that's made up of a number of stacks, then you can deploy individual stacks rather than deploying all of them. Yeah, so the stack is the unit of deployment. Okay, here's your typical, well, I've made that point about developer productivity. I just did a quick little case study for myself. So I wrote a CDK app, and all it does is it creates an EC2 instance. We'll look at this kind of code in more detail in a while. It creates an EC2 instance, and I think that's all it does. The equivalent CloudFormation template has much more lines of code in it than our CDK code. So hence the developer productivity point. So we write our CDK application that's represented by this symbol here. This is our imperative infrastructure as code written in whatever language, TypeScript in my case. We pass that code to the CDK framework, and it outputs the CloudFormation template. Okay, it's declarative, but this is essentially representing your CloudFormation template. So everything comes back to that really behind the scenes. And then from there on, it's the same as if you were writing CloudFormation natively, right? So the CloudFormation template is passed up to the CloudFormation service. It then interprets this and talks to the individual AWS services and tells them to create particular resources and configure them accordingly. Yeah, that's kind of the flow of execution when you're using the CDK framework. this is kind of your workflow, and this is what you'll be doing throughout this module. Yeah, you create a skeleton CDK application first using this kind of command here. You tell it what language you're going to be using. So that will scaffold up some folder structure for you. You can, well, then you would actually write your, in this case, in our case, you'd write your TypeScript code using the class library that comes with the CDK framework. And you can then, if you run this command, then it will create the CloudFormation template. Now, we don't tend to use that command that much, but that's what it does. What we tend to do after we've written our code is we tend to issue this command. And when you issue the CDK deploy command, if I go back to the previous screen, that's what triggers kind of what goes on over here, right? It triggers kind of the creation of the CloudFormation template, uploading it to CloudFormation service, and so on. So it's a simple command and nothing else, CDK deploy. If you have a multi-stack application, you need to tell it which stacks do you want to deploy. Or you can say minus minus all, and it deploys all of them. Great, so we've done CDK deploy, and let's supposing it has created our infrastructure and everything is fine. We can then, if we want to change the configuration of certain parts of our infrastructure, we go back to our TypeScript code, make the necessary edits to it. In other words, change the state of our infrastructure, and we just go CDK deploy again. In this case, the CloudFormation service already knows about your application, so but it will, the CDK deploy in this case will again create a completely new CloudFormation template. And if I go back to here, that template then will be uploaded to the CloudFormation service, but it will kind of do a diff between the new state and the state that currently exists. It has a record of the current state of the infrastructure, work out what changes need to be made, and communicate those changes to the services. So again, like I said, all of what's going on over here is everything that you know already about CloudFormation from last year's module. And in a sense, we don't really care as long as we understand how to write this stuff, and we can correlate it with what resources have actually been created. Then we don't care about the kind of middleman in a way. If you want to remove the infrastructure that has been created, it's a simple command, CDK destroy, and that triggers the removal of the various resources. Again, it goes via the CloudFormation service. So there's constant communication when you do CDK deploy and CDK destroy. There's constant communication going on between your terminal really and the CloudFormation service. The CloudFormation service kind of keeps reporting back to you where it's at in the deployment stage, if it's deployment, or where it's at in the destruction stage if you want to destroy. And we'll see that when we play with it. When you create, sorry, if I go back to here, when you do CDK init, then this is the folder structure that it creates. So this is the structure of a CDK project. And some code has already been created for you. So the TypeScript file in the bin directory, we refer to the code here as being kind of the entry point. So what I mean by that is when you go CDK deploy from the command line, it first of all kind of executes the code here. And there's usually very little code in this file, in this entry point file. But all that typically goes on inside it is it creates an instance of the class that you have defined inside in this file. It's this one here is where you put all of your infrastructure code. or it's here where you put, sorry, these are often referred to as the stack files. And if you only have one stack, then there typically is only one file in the lib folder. Although later on we put other files in there as well, even though they won't be stack files. And it creates, and a stack is essentially just a class, as we'll see. So what this one guy does is it creates an instance of that class and other stuff as well. The rest we don't really care about. I won't ever get into testing, so we can ignore that. And it's essentially it's an NPM project because there's a package JSON there. That's because we are going to be writing our CDK apps in TypeScript. If we wanted to write our CDK apps in Python, for example, then clearly you wouldn't have package.json files. You'd have a required.txt file, I think, isn't it? And there's also tsconfig, by the way, as well. If I switch over to what do I want to do? Okay, if I just I go back to so an application is made up of stacks, and a stack is made up of constructs. Okay, so just focusing on constructs. There are three types of constructs that come uh, with the CDK framework, L1 constructs, L2, and L3. We mainly use, in fact, if not exclusively use L2 constructs, but just to quickly go through them. An L1 construct, and each of these constructs they're all TypeScript classes. So we've got lots of constructs which are implemented as classes, and they're of type 1 constructs, similarly for L2 and L3. But when you use one of the L1 constructs, what that typically does is it just creates a single AWS resource. So that there's kind of a one-to-one relationship between an instance of an L1 construct and a piece of infrastructure. Yeah, it's one-to-one. In the case of an L2 construct, when you create an instance of an L2 construct in your code, there tends to be a one-to-many relationship between it and the amount of infrastructure it creates. So clearly these kind of L2 constructs, from a programmer productivity point of view, you have to write less code in order to create a number of resources or a number of infrastructure instances on the cloud. So, maybe you might use a particular L2 resource that, let's say, it creates an EC2 instance. It also creates a security group. It creates an IAM policy. All of those are created as a result of one L2 construct instance. An L3 then is better again. Like an L3 almost creates an entire um, sub application, if you like. We won't use any L3s. Okay, let's look at some actual code. Notice now that we're very tight on time, so we probably won't get there. But let me just load it in anyway. Okay, so this is our first CDK application, and the folder structure is, as I mentioned on the slides. If we look at uh, this file, very little in it, just some imports. I'm importing the actual CDK framework itself. I wouldn't worry about this import here. I'm importing a class that is defined down here in my lib folder, which is essentially this one here. Just ignore it, and that class is going to create a stack for me, which we look at probably not today, but that's okay. And what am I doing here? First line of code is essentially create an empty CDK application. The next line of code, what it does is it creates an instance of my custom stack, which I've imported, and I'm essentially adding it or binding it to the application because I'm actually passing in a reference to the uh, application into the constructor for this guy. But we can look at it. We can look at the detail of this probably not really next week. But so we're creating a stack, attaching it to my CDK app. This is just an identifier, custom identifier for my stack. We would see that up in CloudFormation when we eventually deploy it. And then the third argument of this class is this object. And you can see and they're not actually mandatory. Lots of the properties of this object, if we looked at its type definition, lots of the properties are optional, but I've just taken the liberty to specify the account that I want to deploy this stack to. So that's my AWS account ID, and I want to deploy it to this region. Now, as it turns out, I don't really need to pass those two values in at all, because when I run CDK deploy from the command line, if I don't specify these, then it will pick up those values based on the configuration of my AWS CLI. It kind of falls back onto that. I have my AWS CLI installed, obviously, as you will as well. So, I guess it's only if you want to deploy to a region other than your default region and to an account other than your default account, subject to you having permission to do that, of course. Anyway, that's what they do. We look at the detail the next day, but here is the file that contains the implementation of my stack. And it looks like I'm actually creating an EC2 instance. I'm also, I am creating a security group, and I'm making some changes to the security group. And yeah, I don't want to get stuck into this now, really. This is if you remember when you talked about EC2, we had this notion of user data. It's essentially like a startup script for your EC2 instance. That's what's going on here. So it looks like I want to install the Apache web server. If you look at this line here, I want to install the Apache web server in my EC2 instance, and I start it up, and also I'm specifying the actual home page of my web server. And I'll be able to navigate to that web server from a browser to confirm that all of this infrastructure has been deployed and is working. Right, I am going to stop there. I, yet again, will allow people to ask me any questions just before we wrap up, whether they be specific to this or more generally. No. Okay, so work on the TypeScript lab, and at most really all you need to do is to create that IAM user that I talked about. You can walk your way through the CDK lab as well. It's very prescriptive if you want to. There are no exercises. The only thing I would warn you about though, if you do, because this lab, what it will do is it will create an EC2 instance. It'll create an application load balancer and some other resources as well. Now, those resources cost money if you leave them up and running. So if you do poke around with this, do not let the infrastructure, I would suggest don't leave the infrastructure running over a number of days. What you should do is just jump forward to this part here and run CDK destroy, and that will delete your EC2 instance and application load balancers. I'd almost suggest not going near this lab until I walk you through the demo in next week's lecture. Otherwise, you're just going to incur costs. Right. I'm going to leave it at that, and I will touch base with you again next week. Thanks. Bye-bye.